actually two main types of numbers we tend to work with, and those are integers and double, otherwise known as floating point numbers. Integers are essentially whole numbers. Think of things like 10, 12, 100, etc. And on native platforms, those values can range anywhere from -2 to the power of 63, which is some huge negative number, all the way to 2 to the power of 63, which is some huge positive numbers. And technically speaking, it's 2 to the power of 63 minus 1. In other words, integers, those are whole values or whole numbers. Double, that is the double data type, those are floating point numbers, and those are specified by adding the point and then adding in the precision. So for example, 3.14, that's a double or floating point number, and 2.0, because you added the extra precision, that also counts as a double. So let's take a closer look at integers and doubles, as well as being able to use the specific data type in creating a variable. And then we'll also talk a little bit about how to convert from a string to a number, since that's sometimes a common task as well. Let's head over to Dart. We are in Dartpad. Now remember, we mentioned that there's type inference available for us inside of Dart, which means I can say var, give the actual variable name, and have Dart infer what's the best data type given what I'm passing in, like 13 should be an integer. Or I can also specify the exact data type I want it to be by asking for the data type, like integer number 1. In the same way we did that for string, we can do that for floating point integer as well. So I can say double, let's make this number 2, and I'm going to have that be, let's say 12.1. And so just to make sure everything's working, let's go ahead and print one of these like number 2. And let's run this. So here we should be able to see the output is 12.1. Perfect. So again, recall that as we're learning about these different data types, instead of using var, you can technically try to, instead of inferring the data type, have it be forced to a particular data type. So this is integer, this is double. I should also point out, now that we're talking about numbers, there are different types of number notations. You can even do exponents and hexadecimal numbers. We're not going to cover a lot of these, especially not right now. Until we get to Flutter, then some of these cases may actually turn out to be useful. But I just want to quickly show you, since we're on the topic of numbers, let's show you an exponent number. So if I want an exponent number, the way I can define it is something like 1.2 times 10 to the power of 3. You can use scientific notation, and that's actually no problem. So then if I print out exp number, that also works in Dart. So you're going to see in a second 1,200, which makes sense because this is scientific notation. If you're not familiar with this, then don't really worry about it. But again, all this says is 1.2 times 10 to the power of 3. Okay, so that's scientific, sometimes known as exponential notation. And then what I lastly want to show you here is the way to check the runtime type of an object, as well as the ability to convert from a string to a number. So depending on how users end up interacting for applications, sometimes there's going to be a string input that we actually want it to be something like an integer or a floating point number. So for example, I may have like a string version of a number that looks something like this, 14.7. And if I print out that string number, that's going to work fine, but it's technically still a string. And I can confirm that by checking the runtime type. So I can grab string number and then check runtime type. Notice that's an attribute. And then that's going to report back whether or not it's a string or a double. So again, notice the double quotes here. This is technically a string. So when you print it out, it might look fine. So let's go ahead and check that. So okay, 14.7. It's kind of hard to tell from the console's perspective whether this is a string or a number. So that's one issue if using kind of just print statements to try to tell if something's a string or a number. Instead, we can use runtime type attribute to check, oh, in fact, this is a string. So how do we actually convert this? Well, we can ask it to try to parse this string into a particular number type. So how can we do that? Well, what we say here is, let's create a new variable. We'll say this is our, let's say, converted number. And then I ask for the data type I want to try to parse. So for example, I'll ask for double and go ahead and try to parse this. Notice it's telling you this should be a string source, which makes sense. And then we're going to say parse this, and I'm going to pass in the string 14.7. Or what I could do is just pass in the variable as well. I could say parse string num. And now let's go ahead and, whoops, forgot to put the semicolon there. Let's go ahead and print out the converted num runtime type. And then what I'm also going to print out is what it looks like when you actually print it. Okay, so let's go ahead and run this. So what I'm doing here is I'm taking double, and I'm going to go ahead and parse the actual string. So notice string num starts off as a string, but then I can parse it to a double type, confirmed here by double, and then when I print out, I see 14.7, but this time it's actually a double, not a string. So be careful when you're printing things, because often when you're taking user input and you expect it to be a number, it's actually going to be a string, but it's hard to tell just from the console whether you have a string or a double. So you can always use .runtime type to actually check if something is a string or a number. Okay, that's it for this very brief basic lecture. Again, main takeaways are integer, double, and the fact that you can parse things, as well as the fact that you can perform a runtime type call. Keep in mind, parse does have limitations. I can't just do something like, hey, parse 2 into the number 2. This will do an error. So if I run this, it's not going to be able to detect something like, hey, this is an invalid double, TWO. So keep that in mind, but that's the main takeaway here. Okay, coming up next, we're going to have an exercise for you. I'll see you there.